Welcome to Unit 10. We're going to be solving systems of linear equations. So first of all, a system of linear equations is when you have two or more equations with two or more variables. A solution to a system is an ordered pair of numbers that is a solution to each equation in the system. So we're going to be dealing with systems that have two equations and two variables. So we can have exactly one. This is where we end up with an ordered pair, where they cross. Okay, so in this case, it would be 1, 3. Infinite is when the lines are the same. No solution is parallel lines. So what does it mean for an ordered pair to be a solution to the system of equations? A solution to the system of equations is an ordered pair that makes both equations true at the same time. So if we have a system of equations, 12x plus 3y equals 9, and y equals negative 4x plus 3, and it says, is it a solution? So what we're going to do is check each ordered pair in both equations, okay, to determine. So I've made a chart for you to organize your work. You could make one on your own on your assignment, or you can just check it. So here we're going to plug in x and y. So this is going to be 12 times 0 plus 3 times negative 7. Does that equal 9? So that's 0 plus negative 21. So negative 21 does not equal 9. So we don't need to even check here. Okay? Because it was not true in one of the equations, it doesn't matter if it's true in the other equation or not. Okay, let's try this one. So we have 12 times 1 plus 3 times 5. Does that equal 9? Well, that's 12 plus 15, so 27, again, does not equal 9, so there's no need to check on the second equation. So no. Next one, we have 12 times 3 plus 3 times negative 9. Does that equal 9? So 36 minus 27 is 9. 9 does equal 9. So that one works. We got a true statement. Now we have to check the other equation. Negative 9. Does that equal negative 4 times 3 plus 3? Well, negative 9 does equal negative 9. So yes, because it worked in both equations, it is a solution. And 12 times negative 2 plus 3 times 11, does that equal 9? Yes. And here, this one, 11 equals negative 4 times negative 2 plus 3. So, yep, 11 does equal 11. So, yes, that is a solution. Okay, so again, it has to be true in both equations. So for each given ordered pair, we will check to see whether it makes both equations true. If both equations are true, then the ordered pair is a solution to the system. But if at least one is not true, then it is not a solution. Okay. One way that we can solve a system of equations is by graphing. So we've practiced graphing lines. You know how to graph lines. So what we're going to do is we're going to graph both equations on the same ordered or on the same grid, and then we're going to look to see where those lines happen to cross. So here our top equation, our y-intercept is 2, slope is negative 2. And when graphing systems, you need to be very accurate. So I find it helpful to do as many points as possible, especially on your first line. And then when you get to your second line, you can tell where they intercept a little bit easier. So here we start at 1, -1 is our slope, so down 1, right 1. So there we've determined that where they intersect, okay? You do need to draw the lines. I have a lot of students forget to actually draw the line, drives me crazy. Yeah, that doesn't want to straighten. So this solution is at 1, 0. Okay, we start at the intercept. Our slope is 3, so 3 over 1. -7, slope of -4. So those ones intersect at -1, -3. All right, y 4x plus 8. So we start at +8. Our slope is 4. There's not room to go up and right, so we're going to go down and left. Because we're creating a positive slope. Our bottom equation is not quite in slope-intercept form, so we'll distribute. And we got the same exact line, right? So when that happens, there's an infinite number of solutions. Sometimes infinitely many solutions is what is used. Here, let's see, we start at 0, our slope is 3. Now, even if you can tell from the equation, you do need to graph what's happening because we are solving by graphing, so you have to show the graph. Okay, so these lines are parallel, means they're never going to intersect, so there is no solution. Good luck.